dive right into it. So first off, a square root function is going to look like this. So square root function is basically going to look like this, right? Let's just do an example of the easiest one, or the most basic one. Y equals square root of x. So we've talked about what y equals x squared looks like, how we get our parabola. So what's the shape of the opposite of that? What's the shape of y equals square root of x? So let's go ahead and make a table for this and graph it and see what we get. So just like normal, what I'm going to do is I'm going to start with a table. That's always what we do when we are learning a new graphing problem. And I'm going to have x values and y values. And let's take a look at 5 different values that I can plug in. Okay, so normally what I want to do is I want to take negative numbers first, and then go to 0, and then take a couple positive numbers. However, for this type of function, there's something that you have to realize. So we'll just look at one negative number because I think you're going to see something strange happen when you try and plug in a negative number for x. So let's take -1 as an example. So if we plug in -1, the next value we'll plug in is 0, then 1, then 2, then 3, okay? And actually, I know I said we'd only do 5. Let's do 6 just for good measure. So, because we're about to lose one of them. Because what do you notice when you plug in -1 for x here? If you plug in -1, suddenly it becomes no solution. Which means it's not going to work. We can't use -1. Which means our graph actually has a limit here. We need to start at 0. 0 is actually the smallest number that we can plug in and actually get an answer here. So if we plug in 0, we get 0 as our answer. So 0, 0 is going to actually be our first point on the graph. Okay, so there's not going to be an arrow attached to this one. It's going to be a point, and then an arrow is going to come out off of this one. All right, now if we plug in 1 to this, and we have y equals the square root of 1, something that I want you to consider is that we don't want to actually consider the answer when it's negative, because now we're looking at functions where it will specifically say negative on the end here if we want it to be negative, okay? So for this example, if we plug in 1, we actually get 1 as an answer. So we're just looking at one answer for these problems, okay? If I plug in 2, I get the square root of 2. I don't know what that is offhand, so I'm going to have to start using approximations, which is totally fine when I'm graphing, okay? Because when you're graphing, you're just trying to figure out what the shape is going to look like. So let's go ahead and plug in square root of 2. So I do square root 2 equals, and I get about 1.4. So we'll just take 1 decimal point. So about 1.4. Okay, so like I said, it's okay to get approximations. So let's go ahead and plug in 3 and see what we get. So I clear square root 3, which gives me about 1.7. Okay. And then finally, I know what the square root of 4 is. The square root of 4 is 2. Okay. So let's go ahead and start graphing this. And just as a spoiler, we are going to have to add more numbers because this is not going to give us a very good picture of what's happening just yet. Something to keep in mind is we don't need negative x values. So a lot of our graphs for these types of problems are going to look like this. They're going to be pretty heavy on the positive side. because we don't really need to look and see what's going on in the negatives because we don't have any negative values. Okay, so let's go ahead and label this. I'll go ahead and give myself lots of space for my y values. And the reason why is because when you're taking the square root of something, you're not really going to have large y values. In fact, you're going to find that you hardly have any y values that go past a certain point. Okay, so next up, we got 1, 2, 3, 4. So we'll start with 4 for now and see where we go from there. Okay, so let's go ahead and plot our first point. We've got 0, 0. My second point is 1, 1. So I come up here to 1, 1. Okay. My third point is 2, 1.4. So I go to 2, and I go up to 1.4. This one I have to kind of guess about where it's at. Do you see why it didn't matter if we were doing an approximation or not? Because when you go to graph something, you're already doing an approximation. Because you can never really get it exactly where it's supposed to be. Next up is 3, 1.7. So 1.7, I'm going to say is about right here. And then finally 4, 2. Okay. Okay, so we can kind of see the shape here, but I kind of want to get a fuller picture. So what I'm going to do is I'm going to make a prediction. I'm going to kind of do a huge skip in the graph. And I'll probably put a line right here just to show that this is a huge gap right here. So we were going up by ones, but what I'm going to do is I'm going to go up to the very next number that I know I'm going to get a whole number. That I'm going to get a solid answer that I don't have to approximate. So the next number that I can plug in that's going to give me a solid answer is going to be a perfect number, or a perfect square. See how this is 4? So what's the next perfect square? Well, the next perfect square is going to be 9. So it's going to be a big jump. So maybe I need to make some more room on my graph. So 5, 6, oh, now I'm coming off the graph. 7, wait, 1, 2, 3, 4, 5, 6, 7, 8. Oh, it's going to be too far down, so I guess I'll just put it at the very edge of my paper. Okay, that'll be 9. Okay, and the answer I'm going to get from that one is going to be 3. So I'm going to plot that, 9, 3. So 9, 3. It's going to be right here. Okay, now I can kind of see the shape of my graph a little bit more. And I can kind of see that it's like a very weak arc, right? So if I connect all the points here, I can see that I'm going to kind of go up in that direction, okay? All right, so this is kind of the general shape of square roots, is they kind of look like kind of a weakened version of a parabola. And you'll notice that if you were to turn your graph this way, it kind of looks like just one side of your parabola. And if we were to include the negative numbers in our values, so if we were to include all of the y answers, we would actually end up seeing a mirror image on this side, and it would look just like a parabola. So here's the reason why we don't include the negative values. And that's because, remember our original, do you guys remember the original vertical line test? How something could only be a function if you do the vertical line test and it never crosses 2 points at the same time. So if I run this across vertically like this, do I ever touch 2 points? No, I'm always touching just 1 point at a time. However, if this was reflected going this way, I would be hitting 2 points. So we have to specify, and we have to be talking about either the positive version or the negative answer, right? And so now, from now on, it'll be specified. Okay, so let's talk about the domain of this function, because this is probably one of our first functions that we've ever seen all year where the domain actually is what we want to specify. We normally have a different range. Normally the range is doing something weird. But in this case, our domain is not just going to be all real numbers, right? Our domain is actually going to be wherever our starting x value is, and then every point beyond that. So for this, we don't have x values in the negative. Think about that. If we had negative x values, we'd get no solution. So for this, I'm going to say my domain is x is greater than or equal to 0. That's my domain for this function, okay? So I'm going to show you, because we're going to do a couple practice problems here in a second, but I need to show you how you come up with this without needing to graph it, right? So all your graphs are going to have this shape, but let's talk about how to find the domain without needing to graph it first, okay? So to find the domain, what you're going to do, so this is finding domain without graphing. Finding domain without graphing, okay? And here are your steps. Basically, your goal is to figure out when, so let's write this down. So step 1, when does scratch that out. Sorry, my bad. What does x need to be in order to take the square root of 0? And you can write that just like this. So what does x need to be in order to take the square root of 0? Okay, that's what we're going to ask first. And then the next thing we're going to do is we're going to check x values beside our answer. Okay, so those are going to be our 2 steps. All right, and that's going to help us know which direction we go. So as an example, example A, let's just take the one that we just did to see when this happens. So if I have y equals the square root of x, first thing I ask is, what does x need to be in order to make me take the square root of 0? Well, this one's pretty easy, because x would just have to be 0, right? So x is 0. That's when we get the square root of 0. And then from there, I just need to check both sides. So first, let's take 0, and let's check the left side first. And then we'll check the right side. Okay, so what happens when x equals -1? Well, when x equals -1, if I plug that in, I'm taking the square root of a negative. So that's no solution. So that means I can cross this one out. That's not the direction I'm going. What about when x equals 1, though? Well, when x equals 1, then y equals 1, which means that works. Which means I do get an answer when I go to the right. So if I get the answer when I go to the right, that means my x values need to be 0 or greater than 0, right? Because we plugged in 1, and 1 is greater than 0. So our domain ends up being x is greater than or equal to 0. And that would be our answer for this one. Okay, because the 0 comes from here, and the greater than comes from here. Okay, what I want you to do is go ahead and do page 504, numbers 1 through 3, all, and we'll come back.